Hello, welcome. We're going to solve some trigonometric equations. You've solved them in M4, so we're going to recap on those and then add in new equations to solve. When you were solving these in M4, you would find where the sine of theta was square root of 3 over 2. So if I look on my unit circle, sine are the y values. Sine equals the square root of 3 over 2 here and here. Remember, these are negatives in the lower quadrant, so it doesn't count. So therefore, you would have two answers, pi over 3 or 2 pi over 3. Also very important to note is you can write your answers two ways. If I said, what are all of the answers between 0 and 2 pi, you would tell me pi thirds and 2 pi thirds. If I was not specific or tell me all answers, you would say that this repeats every 2 pi n. Because when I do a full circle and stop here, that has the same height. 2 full circles up here, same height. And similar with the bottom one, plus 2 pi n. All right. So there would be my answer. Since I was not specific here and I just said solve, you add plus the 2 pi n. Not specific, assume it means infinite number of solutions. So let's solve where the tan is 1. Well, the tan is 1 here because it's sine over cosine, which gives me 1. And it's also 1 down here in this quadrant. Notice how that repeats every pi, every half circle. So I would just write that it's pi over 4 plus pi n would be all the solutions to this equation. I add the plus pi n because I'm not being specific on a range, on an interval. I want all possible answers. So I'm writing pi fourths plus pi n. I do not want to write both answers plus pi n. 2 pi n. I want to be as short and sweet as possible. Third equation. Cosine is 1/2. Well, where is the cosine 1/2? Those are the x values. Cosine is 1/2 here, and it is here. That does not repeat on pi. So therefore, it's pi thirds plus 2 pi n. And the second one is 5 pi thirds plus 2 pi n. 5 pi thirds plus 2 pi n. And that will give me all possible solutions. This is the same that you did in M4. Now, this one is a little bit trickier. Hopefully you saw that in M4. If not, we can get you caught off real quick. Cosine of 2 pi is square root of 3 over 2. So I just find out where's the cosine value, root 3 over 2. That would be here. And that would be here. So I have two answers, where 2 theta is pi over 6 and plus 2 pi n. And I also have the other one, which is 11 pi over 6 plus 2 pi n. Okay? This is getting messier and messier. Equals 2 theta. Now, I have to solve each of these equations. I don't want 2 theta, I want theta. So in order to get rid of the 2 theta, I divide by 2. But I need to divide every last piece by 2, including the 2 pi n. So therefore, theta would repeat every pi twelfths, which is pi over 6 divided by 2, multiplied by 1/2, plus pi n, and divide everything by 2. This is 11 pi over 12 plus pi n. Notice how I divided every piece by 2. Just remember, divide by 2 is multiplied by the reciprocal, which ends up to be times 1 over 2, in case you were curious where I got that 12 from. So a logical next step is to solve equations like this. This screams factoring to me. Difference of squares. 2 cosine minus 1, and then 2 cosine plus 1. Then I can set each piece equal to 0. So then I get cosine on this side. Cosine equals a positive 1/2. And then cosine equals negative 1/2. Doing this in calc the other day. So I need to go to my unit circle, and I need to identify the spaces where cosine's positive 1/2 and where it's negative 1/2. And here we are. Now we have some very nice repeats because this repeats, these two repeat every pi. So I can condense my answers because I can say it's pi over thirds, pi thirds, plus pi n. That takes this guy out and this guy out and all the repeating ones. And then I have 2 pi thirds plus pi n. 2 pi thirds plus pi n. And that takes this guy out and that guy out. Notice how it is not on an interval, so I give the plus pi n answers, or 2 pi n. This definitely screams factoring to me. It is a trinomial, so I get a sine squared down low and a minus 3, which tells me I'm going to have a sine minus 3 and a sine plus 1. And now I'm going to go and write that out. When I set each equal to 0, I get sine is negative 1. And I also get sine is 3. Well, the sine is never 3 because sine values range between negative 1 and 1. So I will not get an answer from this, but I will find where sine is negative 1. Sine is negative 1 here, and that's the only location. So my answer would be 3 pi over 2 plus 2 pi n. So let's go a full circle to repeat. Now, secant x minus 2 equals 0. This is just something random. We're not solving. First, we're verifying. How would you verify that this is a solution? Well, I would go to my unit circle and find out secant at pi thirds. What is the secant at pi thirds? Let's look. Secant at pi thirds, secant. 1/2 is the cosine. If 1/2 is the cosine, secant is the reciprocal, which is 2. Does 2 minus 2 equal 0? Yep, that is a solution. Let's verify that this is a solution. This is how we check our answers. 5 pi over 3 here. And secant again, so I'm just looking at that x is 1/2. Reciprocal of that is still 2. 2 minus 2 is still 0. Yep, that one also works. Okay, so let's solve these equations. So sine equals negative 1/2. Looks like from the Trunkamunk days. Sine equals negative 1/2. Where does the sine equal negative 1/2? Well, negatives, negative 1/2, negative 1/2. So I will have 2 answers for this. My 2 answers, one is 4 pi over 3 plus 2 pi n, and the other is 11 pi over 6 plus 2 pi n. Now, all right, so then what I would do to solve the bottom equation down here, you notice how it jumped up, I would go and I would get tan equals negative, that's a negative root 3. I find that on my circle. Where is the tangent of negative root 3? Well, it's where you get root 3 over negative 1 or negative root 3 over 1. That repeats every pi n. So therefore it's 2 pi thirds plus pi n. Now when I'm solving this equation, I need to set each factor equal to 0. So I'm going to start with the left side. Tan squared is going to equal positive 1/3. And then tangent's going to equal plus or minus the square root of 1 over 3, which breaks into plus or minus 1 over root 3. Normally I would tell you to rationalize that denominator. However, in this case it's not very helpful because tangent is sine over cosine. And it's easier for me not to rationalize because the sine is 1 and the cosine is root 3, or any positive negative combination. So again, the sine is 1 and the cosine is root 3. Sine is 1, sine is 1, and the cosine is root 3. Sine is 1, cosine's root 3, sine is 1, cosine is root 3. Any positive negative combination. So those are my answers so far. Now let us go over to this one on the right side, and I need to set this equal to 0. So I'm looking for where the tangent squared equals 3. So I'm looking for where the tangent equals plus or minus root 3, which has an imaginary over 1. So I'm looking for where the sine is root 3 and the cosine is 1, and any positive negative combination of that, which are all these answers. Now I can start listing out all my answers. I'm going to say pi over 6. Whoops, I'm going to use a new color. I'm going to do red. I'm going to do pi over 6, and that repeats every pi n, and that would nail out this guy and this guy. I'm going to do pi thirds plus pi n, and that's going to take out this guy and this guy. I will do 2 pi thirds. 2 pi thirds. I'll box in my answers on my homework because I'll make it neater. Plus pi n. That repeats here and here. And then 5 pi over 6 plus pi n. And that gets me my final 2 answers across one another. Box it in. Wah. There we go. So now it says find all the solutions on this interval. Careful, please note, sometimes you'll see a solid bracket here, and sometimes you'll see one on the other side. What that means is if my answer, this is 0 and this is also 2 pi. The bracket means it includes this value. So if I were looking for an answer at this location, if this is the interval I want my answer on, my answer would be 2 pi. However, if my interval was curved on this side and rectangular on this side, it means my answer would be 0. Set notation, it means I want all answers from 0 and including 0 up until 2 pi. And then if you rearrange it and make the bracket here, that means I want all answers between 0 but not including 0 to 2 pi including 2 pi. So I'm going to solve this one real quick here. Secant equals 1. Secant squared equals 1. So therefore the secant equals plus or minus 1. Plus or minus 1. Secant is 1 over cosine. So therefore cosine is the reciprocal of this. So we want where cosine is plus or minus 1. Oh, where's cosine plus or minus 1? Well, cosine, let's pretend that this is our thing. Cosine is here. Whoops. Cosine is here and here. -1, +1. So I am looking, I do not want to plus pi n because I'm on an interval. So my answer will be pi, comma, 2 pi. Because I have the bracket here, I am including 2 pi but not 0. This answer would change if the bracket were on the other side. Let's just do that for a second. Say this was a bracket and this was a parenthesis. My answer would be pi and 0. All right, I think this is going to be the finale. Let's factor this guy up. Then we're going to set it equal to 0. And I just list my answers with nothing added to it because it's on an interval. That's it.